in this video, we will revisit the linear probability model that was covered in chapter 7. Now, if you think about a model where the dependent variable y is binary, or it just takes 0 or 1 values, there's typically the violation of the MLR5 assumption of homoskedasticity, which is to say that heteroskedasticity must be present if xj is affecting y. So the simplest solution to address that in the linear probability model is to use heteroskedasticity robust inference after you have estimated the model using OLS. We could use weighted least squares, but these are very cumbersome and really rarely worth the effort. Now I would like you to go back to the example that we did with Apple data a couple of videos ago. And what we're going to do is this time around, we're going to actually generate a binary variable called ecobias. So if you think about what we were doing a few lectures, a few videos ago, we were basically using Apple data and we were estimating a demand function where we had the quantity of apples that were eco-labeled, and we said that that depends on the price of eco-labeled apples plus the price of regular apples plus other variables like income and the number of people who are a bit, falling in the household that are between certain age groups. So anyway, what we want to do is we want to convert this variable, which is actually quantity, which is measuring the quantity of eco-labeled apples in pounds, to a binary variable, which is just going to be ecobias. So ecobias is going to take two values, is 0 or 1, or false and true, basically, which is going to tell us whether you are buying eco-labeled apples or not. Okay, so 0 if you're buying, so 0 if you're not buying, eco-labeled apples, and 1 if you are buying. Okay, so we want to do that for each person that is in our data set. So what we can do is we can construct a new data set, which is called Apple New. Okay, again, lack of creativity there, but basically we're going to assign this name to our new data set. So we're going to take the original data set, which is Apple, and we're going to mutate on it. Okay, so we're going to mutate and construct a new variable, which is called ecobi, which is going to be, now this is a test that we're doing. We're saying ecobi equals ecopounds greater than 0. So we're testing if ecopounds is greater than 0 or not, right? So this is a variable that's going to take true and false values. So think about this. If pounds equals, let's say somebody bought 1 pound of apples, 2 pounds of apples, no apples, or 0 pounds of apples, 3 pounds of apples, then what this is doing is saying ecobi is going to be, if this is 1, then this is going to take a value of true, false, right? Because this is testing. Ecobi is saying, is ecopounds greater than 0? Is this guy greater than 0? So is this greater than 0? True. Greater than 0? True, right? And then this is greater than 0, false, right? So it's testing that condition, greater than 0, true. So that's the data set that you're constructing. And then we can always look at the table and we can see, how many times was it true and false, right, in our data set. So what we can do then is run that linear probability model. This time we're not going to put ecopounds on the left hand side, but we're going to put ecoby, which is the variable that we constructed, which is taking true false values or 1 0 values. Okay, so we're going to regress it on the same set of regressors that we had, but remember that we're going to use our new data set this time. And then we're going to use Stargazer to report our regular regression from OLS and then also our robust regression like we've seen before. And here you're going to notice that the output didn't change that much if we compare the two regressions here, right? So if you notice, these are very close. The standard errors are very close here. In some cases, this is higher. In some cases, this is lower, the standard errors, but this is very, very similar. Okay, so even though, here, it didn't serve too much of a purpose, but, the thing to remember is that even though we know there is heteroskedasticity, when we are working with a linear probability model, the usual robust standard errors are pretty similar in this case, okay? But the way you're going to interpret this is going to be the following. We're basically, if let's say we wanted to interpret this, we're basically saying that as the price of the eco-labeled apples rises by $1, this reduces the probability of buying eco-labeled apples by 83% or by 0.83. Okay, so this is important for you to remember how to interpret these coefficients. All right, so that's the end of chapter 8.